Okay, good morning. Hopefully everyone had a good weekend. All right, so let's look at the syllabus before we do the review here. All right, so we're finishing up the first third of the class. So this is, I think, week 5. And so after this week is done, you're a third of the way through this semester and this class and the rest of your classes. So we finished up these 2 exercises last week. Okay, example 4.3 and 4.4. So those are due today, and I'll get your grades updated on the rest of the assignments later this week. But yeah, and then we're going to do a review session for the midterm today, and then after we're done with that, assuming we finish it today, and so this week I'll kind of go. Let me type in the chat what we're doing today and Thursday. Okay, so hopefully this is clear. So midterm 1 review today, which will start in a minute. And then Thursday, like I said, if we don't finish the review today, we'll finish on Thursday. If we have plenty of time to do it today, which I think we will, but I'm not positive. So if we finish the review today, then Thursday will just be office hours and any questions about the exam. And so that depends on how much we get to today. And then I'll post the midterm 1 to Blackboard after we finish the review, and then it's going to be due via email, which is there's instructions on the exam once we get to it. Okay, so what we need to do is do some practice problems and review for the midterm 1. So if there's no questions about any logistics, we'll go ahead and start that. So if you have any questions, let me know. But let's go ahead and start the. So I made the midterm 1, obviously, which I'll post a little bit, and I also made a practice exam, which we're going to go through right now to prepare you for the exam.
Excuse me, Professor?
Yes.
After I go to the Blackboard, I opened the midterm 1, and I saw 2 forms. Are they the same one?
Yeah, I posted one as a PDF and one as a Word file, but it's the same exact thing.
Okay, thank you.
Yep. Okay, so let's. Okay, if you example 4.3 and 4.4 due this evening. Yes, that's correct. Yeah, so those last 2 exams or those last 2 examples are due today. Yes. Okay, so if you go on Blackboard and you scroll down where it says Midterm 1 Fall 2020, I posted yesterday, I believe, a practice exam. So they're both the same thing. So here's the PDF. So alright, so let me just run through the practice exam, and then we'll solve it in the Word file. Alright, so just a summary of what to expect on your exam. So there'll be 7 questions. So I kind of tried to pick one question from each of the kind of practice problems we did throughout the semester so far. So you have one question on the first example we did, on the bookshelf cost one. So that's number 1. Okay, you'll have one on the quality discounts, the next example we did, so one on that one. Okay, number 3 will be about the golf club demand, where we did the estimating the curve. Alright, so one on that one. Number 4 and number 5 are both on net present value, because those are pretty short. So a couple from that section. And then number 6 is on the basic and XP computers, including some of the shadow price and constraints. Okay, and the last one, number 7, is on the last one we just did, is going to be example 4.4, the oil and heating oil one, where we'll again talk about the constraints and the shadow prices. Okay, so I tried to pick kind of one similar example to what we did in the practice problems that we did in association with the examples in class. Okay, and so here's the practice exam. The exam I'm going to give you after class is very similar, but let's go through this one and let me know if you have any questions about this. Okay, I'm going to open up the Word file. It's the same thing, but I can solve it. I can't solve the PDF, so it's easier for me to solve by typing in the Word file. All right, so here we go. This is the practice exam. Let's start solving it. And if there's questions, please post them or let me know. Okay, so number 1, you've got a printout of something similar to what we did in the bookshelf cost one. All right, and this is the screen cap, and then you have some questions that go along with it to fill in some missing information. Part A, what was the total cost for a cherry bookshelf in year 6? So remember this, you're trying to incorporate the 2 costs, the labor cost and the raw material cost. Okay, so you got, here's the cost of, what is this? The cost of cherry board feet, the cost of oak board feet, and the cost of labor in year 6. And you know how many, you need 25 of each, and you need 5 labor hours for each of the things. So you have to add up the cost, both things, and how much you need. So let's start with the board feet. Okay, so you need 25 board feet, and it costs in year 6, $5.31 per board foot. Okay, so that's for the board feet, and then you need 8 labor hours. See up here? Okay, and that costs now $28.15. So the total cost is the sum of those two costs. All right, so if you put this in your calculator, you'll get something like okay, so it looks like about $273.50. That seems right, yeah. And then let's do it part B. What's the total cost for an oak bookshelf in year 6? So again, you have to add up the two costs. You need again 25 board feet. Okay, for the oak, it is $6.37 per foot. All right, and then the labor cost is the same, so 5 times $28.15. Looks like this one is $300 exactly. Okay, so that's how you calculate the total cost for the two types. And then part C is to do what's the percent increase in cost from a cherry bookshelf from year 5 to year 6. Okay, so use the cost you just got. So the cherry went from $2.69 to $2.73.50. So the percent change is the difference over the original, right? So okay, so the new value increased to $2.73.50, and the original was $269.39. So the difference or the change over the original is this. All right, and then if you put that in the percent terms, it's about 1.5%.
Where'd you get the 273.1?
So that's, we calculated that here. So we calculated the total cost for cherry bookshelf in year 6. So with the 273.50 goes here, right? We're figuring out this number. And so therefore the price increased from 269 to 273. Yeah?
Okay.
So that's the one you got in part A.
Okay.
Alright, so that percent comes out to about 0.015, which is roughly 1.5%. Alright, so all we did here is part A, you got the value for year 6. You already had the value for year 5, and so the change was going from 269.39 to 273.50. And we calculated the increase, which is about 1.5%. Alright, let's do the same for the increase. What was the percent increase in cost for an oak bookshelf from year 5 to year 6? So that went from $295.66 to exactly $300. So we'll do the same process. Okay, so 300, the change over the original, 300 minus 295.66 divided by 295.66 for the increase in 5 to 6 for the oak. And this one is about 0.0147.
Hey, Professor, can you go over how you got those numbers again? My laptop kind of glitched out for a second.
Yeah, no problem. Just look once, of course. Alright, so they're both about 1.5%. I'll just keep it simple. Okay, so for part C and part D, you're calculating the percent increase, okay? And so in parts A and B, you've got the total cost for a cherry bookshelf in year 6, which was $273.50. And then in part B, you got the total cost for an oak bookshelf in year 6, which is $300. So those go there. You're calculating these missing values. Okay, so in part C was what was the percent increase from year 5 to year 6 for cherry. Okay, so you know now that it went from $269.39 to $273.50. Okay, so the percent increase is the change over the original, or the difference over the original. So here's the new value. Here's the old value. So the difference is 273.50. That comes from here. Minus 269.39. That comes from here. Alright, and then divided by the original, 269.39 is here. So the percent in decimal terms is just the difference or the change over the original. And that comes out to roughly 0.015, which is in percent terms about 1.5%. Now the same thing for the oak. The same process, the change or the difference of the original, and the year 6 value is 300. The year 5 value is 295 and 66 cents. So the new value is 200. Okay, 300. The old value from year 5 is 295.66, and then divided by the original of 295.66 here, and that gives us about the same, if you round decimals, 0.015, and that's, again, in percent terms, roughly 1.5%. Alright, so I think the major questions were, how do we get these numbers? So does everyone see how I got these now? It's just the difference, the change over the original from year 5 to year 6. Okay, so everyone's good on this one, and yes?
Yes, sir.
Okay, let's go on to number 2. Alright, number 2, we have, let's see, what do we have? This is the quantity discount one, where we did the ordering cost. Here. Can one of you turn your audio off? Okay, there we go. And, alright, so we got these books at the regular price and the leftover price, and the cost depends on how much we order. Remember, the key here was there's quantity of discounts based on you get a discount if you order more. So we sell the books at $15. The leftover price is $5 if we overshoot demand. And based on the number we order, it is one of these costs. And we decided to order 100, and demand was 100. So part A, here's the calculated revenue. Alright, so revenue is based on how many books are sold, and, well, I guess we have to figure out first how many books are sold at regular price and how many books are sold at leftover price. So we'll do that first, and then okay, so there was a little formula for this in the model, but it should be pretty intuitive how this works. So the point here is that, or for the revenue side, is if we order the right amount of demand, then we sell them all. But if we order too little or too much, then we can sell them at a discounted rate because demand was not as high as we expected. So what we sell at regular price is based on how many we order versus what demand is. So you can see that demand is 100, and we ordered exactly 100. So that means we're going to sell everything in this case because we didn't, like, the two values are the same. So if we were to order too much, then we'd have to sell the other ones at leftover price, and so on. So you only get the leftover price if you order more than demand is, because there wasn't enough to buy the regular price. But in this case, we order 100, demand is 100, so we sell everything at 100. The units we sell at regular price is 100. Okay, and then by default, you can see that we don't have any leftover to sell at leftover price because this 100 we ordered, that was demand, so we sell them all at $15. So there's, in this example, nothing sold at leftover price because there's nothing left over. Okay, so do we see how I got those numbers? Alright, and then the revenue, so you got to figure out units sold at regular price and units sold at leftover price before you determine revenue, because revenue is based on how many books you sell at regular price and how many books you sell at leftover price. So I'll write the full equation here, even though leftover price is going to be 0, but let's just put it in there so you can use it for your exam. Alright, so revenue, remember we did the model, we just had units sold at regular price times regular price. So the price of regular price books is 15. And we are going to sell 100 books at regular price. We just figured that out. So 100 times 15. And then just to be thorough, I'll put the leftover price component in here, even though it's going to be 0. So the leftover price is $5. But we're not selling any, so that's going to be a 0. Okay, so this part is the price of the leftover books, plus the price of the regular books times how many we sell at regular price, plus the price of the leftover books times how many we sell at leftover price. So it's going to be 15 times 100 plus 5 times 0, which is just 1500. Alright, so we're going to figure out the cost, because the cost is based on how many books we order. Okay, so we have to pay for the number of books we order, which is 100. And then, what is the price per book? So you got to look at the table and determine what your price is. So based on this chart, can someone tell me what the unit cost is per book? So what's our price if we order 100 books? Yeah, $9, right? Exactly. So you just look at the chart, and if you order less than 100, it's $10. If you order at least 100, which we did, that's $9. Okay, and it's not until you order 200 you get a cheaper discount. So you get the lower price if you order more than or equal to that amount, or if you're below in this bracket, then you get the lower price. So look at the chart and determine what your price is based on the quantity discount chart. Okay, so then our cost is just 100 times 9, which is 900. And then profit, profit is, we know, just if there's only one good we're selling, or just in any case, it's revenue minus cost. So profit, actually profit part C. Okay, profits revenue minus cost. Revenue is 1,500, cost is 900, and that gives us a nice profit of $600, right? Okay, so for part C, profits always revenue minus cost. So even if you were to miss a calculation or something for part A and part B, still do your revenue minus your cost, because I would still give you credit for that, even if you got B or C slightly off. But the key here is, first of all, to determine how many books you sell at regular leftover price. Okay. So that goes in here, and then also you got to make sure you know how to look at this, the cost structure, and determine your price per books. And once you get here, it's easy. Okay. Any questions on number 2, the quantity discounts problem? Okay, number 3 is on the golf club demand one. All right, and so this you should be extra familiar with, because you have that the curve fitting assignment as well. So this one's not too bad, but all right. Number 3, you get some similars. You get 12 months of data, and you get different prices, and you get the demand associated with the prices of those golf clubs. All right, and then I estimated the trend line, all right, in the graph over here, and then I got the parameters, and so all you got to do is use those parameters to answer questions A, B, and C. All right, so part A, using the parameters, write out the equation for the linear curve. All right, so you did this in your curve fitting project as well, or homework, whatever it is. So here's the equation. All right, so your y variable is demand. You're trying to see how price affects demand. So demand equals. And you can start with the intercept. So the intercept of this relationship is 211.59. Okay, and then it's plus the slope coefficient times the x variable. So the slope coefficient is negative 0.34. Okay, and then the x variable, what affects demand here is price. Okay, so that's all you have to do is define the linear equation based on these parameters. So demand equals 211.59 minus 0.34 times price. So that defines this line, which is exactly the best linear fit effect of price on demand. Okay, what does the slope of this curve imply exactly? So all you have to do is interpret what that negative 0.34 means, which is exactly the relationship of this linear effect.
Professor, is it just minus 34 or is it minus negative 0.34?
It's minus 0.34, so you could add the minus 0.34, but don't minus the minus because then that would be a positive, right?
Mm-hmm. Okay.
So yeah, it's the general form is like this. Basically like that, so demand equals intercept plus slope times price, but because it's a negative, you want to make sure that it gives you the negative effect. So it'd be okay to say plus negative 0.34, which is the same as minus 0.34, but don't minus minus, because then it's technically a positive. So either do it like that, or you could also do it. Okay, so either one of those is the same exact thing, and each one of those is perfectly fine. Okay? Does that answer your question?
Yeah, thank you.
You're welcome. Okay, so we're interpreting the coefficient of negative 0.34, which is exactly the effect of a 1 unit change in the x variable on the y variable. So let's start by saying if...
Professor?
Yes.
May I ask a question for question A?
Yes.
So for demand, for example, like month 1, actually you mean like 211.59 minus 0.34. The price is that 400?
No, the price is 400 in the first month, but so this is like demand is the y variable, which is demand. So this is demand, and then price is the x variable, which is these values. So we're defining the relationship over here where we're this given these prices, what would demand be? So how does it fit on the line? So for example, if price was 400, it would be right here on the line.
Oh, so you already got the demand in this picture, right?
Yeah. So we're writing the equation for this line. So this line here is the estimated linear relationship. Right. If we can simplify it to a linear relationship, then this line is it, and then this is the line. So this line here it starts at 211.59, and every time we plug in a price, the best guess is to multiply it by negative 0.34. So the price isn't 400 because that's the data. So if the price was 400, you plug it in here, and that would say you're here. If the price was 300, you plug it in here, and that would say you're right there. Okay? So this
But
the
why
price.
month 1 and month 12 are similar, but their demand are different?
Say that again?
Month 1 and month 12, their price are 400, but why their demand are different?
Okay, so the months 1 through 12 are the different observations. So you can, this is the price and demand in month 1. This is the price and demand in month 2. This is the actual data. So what we did was we plotted all these points, like 450, which is that one, and we plotted 300 and 100, which is that one. So we plot all these points, X, price and demand 1, price and demand 2, price and demand 3. So these are all the 12 points, right? And then what we did is we used the trend line to get the best fitting linear curve that estimates this relationship between price and demand. So when price changes, what happens to demand? Now it's hard to see with just the dots, but if you can put this line in, this tells you at least a simplified linear version of what happens when price changes. So this tells you that when price goes up, demand goes down by 0.34. So see these dots over here are all the data points of price and demand. And so the month isn't on this picture. The month is just the piece of time it came from. So in terms of the equation and the graph, the months aren't on there.
Okay, thank you a lot.
Okay, so does that make sense?
Yeah.
Okay. Okay, but we can use the months don't play into the calculation, but we can use the months in our interpretation maybe. So okay, so we can say that over the 12-month data sample, this happened, or this is what we saw when price. Okay, when price increases by 1 unit, which is $1, then the negative 0.34 is the effect on demand. So when price goes up by $1, then what the equation says is demand decreases by 0.34 units, which is golf club size. Okay, so this is how you interpret it. So over the 12-month data sample, when price increases by 1 unit, which is $1, then demand decreases by the coefficient, the slope coefficient, 0.34 golf club size. Okay? Yeah, and then C has the law of demand hold in this simple model, and Y, and so remember this is just the law of demand creates a negative relationship between price and demand, or price and quantity. So in this case, when price goes up, demand goes down, which is obviously confirming the law of demand because you get a negative curve. Okay, so the law of demand holds because there's a negative relationship between price and demand. So that means when price increases, demand falls, and vice versa. Okay? So for part C, you're basically checking if the slope coefficient is negative. If it is, then it's going to hold. If it's not, then it does not hold. Okay, so part A, write out the equation. Part B, make sure you can interpret the slope coefficient. Then part C, check the slope coefficient for negative or positive, which will tell you if the law of demand holds or not. So questions on this one, and usually this one, part B, is the part with the most problems. So make sure that part B is clear. All right, so it seems like we're okay so far. Let's go on to number 4. And number 4 and 5 are just quick net present value ones. So we did some like this at the end of that exercise. So number 4, suppose that the interest rate is 5%. What's the future value of $100 10 years from now? All right, so you're going to calculate the future value just using the interest rate and the number of years it compounds. Okay, so just in, oh, sorry, the general equation, which is on your study guide somewhere, is the future value is the present value times 1 plus the interest rate raised to n, because this is the number of years it compounds. So you can just use that general equation, which is here, and let's get the future value of $100 10 years from now at 5%. Okay, present value is the $100. Okay, so you get 1 plus the interest rate, and the interest rate is 5%, so that's 1 plus 0.05, which is 1.05. And that's going to be compounded for 10 years, so n is 10. All right, this will give us, I'll put this in the calculator. All right, so about 162.89, and I'll just simplify it to 163. All right, part B is easy. It's you got part A. So how much of the future value is total interest? We started with 100, and we got 163, so we obviously gained $63 in total interest. Okay, part C. How much would total interest be greater at 6% interest rate than at 5%? So this one just gets the future value using the 6% rate, and the difference or the additional interest is the answer. So first we're going to get the future value where everything's the same except for the interest rate is now 6%. Okay, so see I'm using the same exact formula. The only difference is the interest rate went to 6%, which means that 1 plus I is now 1.06, but the remainder of the calculation is the same, but we should get something a little bit higher. Alright, so we got about 179.08. We'll just say that's 179. Okay, but the question was, how much would total interest be greater at 6% than at 5%? So here we got total interest of $79. The previous time we got 63. So the greater, or how much will be greater by is the difference. Um, 79 minus 63, which is 16. Okay, so alright, so total interest will be greater by $16 at a 6% interest rate. Alright? Okay. Questions on number 4? So make sure you use this formula for those calculations. Alright, number 5. Okay, another one similar to what we did after the net present value example. So here we get a disc jockey is contemplating the purchase of a new turntable that will cost $1,000, has a useful life of 5 years. The turntable is going to yield year-end revenues of $500 in year 1, $100 in year 2, $100 in year 3, $100 in year 4, and $100 in year 5. So we need to calculate the net present value of the turntable if the interest rate is 5%. So what is the lifetime? We have to add up all of the stream of payments or the stream of revenues and then subtract the cost. So first, let's start adding up the 5 years of revenues. And you have to multiply those by the discount factor. Okay, so let's start with the first year, which is 500 we get. And remember for this one, if you're doing the present value, you got to multiply or divide by 1 plus the interest rate raised to the current period. So let me see if I can make a Okay, so I'm trying to write a general formula so you can have it here. Okay, so the net present value is the sum of all the future values in that current period, and then divided by 1 plus I, the interest rate raised to the current period. Then after you do all the sums of all the payments, you gotta subtract the cost. Okay? So the net present value is the sum of all the future payments discounted minus the cost. Okay, so let's start summing up all the discounted payments, or the discounted revenues. Year one, we get $500, and that's divided by 1 plus I to the 1. Okay, so that's the first one. And then year two, we get $300. And that's divided by 1 plus the interest rate squared, because it's in year two. You gotta wait 2 years. Okay, so we get the idea. In year three, we get $100, and we get $100 on the last, in years 3, 4, and 5. So, $100. Okay, so we summed up all the future values discounted, right? So we got $500 divided by 1.05 in the first year. Second year, 300 divided by 1.05 squared. The third year, 100 divided by 1.05 to the third. The fourth year, 100 divided by 1.05 to the fourth. And the final, the last revenue, year 5, 100 divided by 1.05 to the fifth. And the last thing we have to do is subtract the initial cost, which is $1,000. Alright, so if you put this in a calculator, or you use your financial calculator or whatever, you'll get something like okay, so when you add up all the payments and you subtract the cost, you get something roughly like negative $4.69. Okay, and so that's including the cost. So should the DJ purchase the turntable? So if all of the payments, all the revenue payments, are here, and then we subtract the initial cost. So that means that the investment isn't worth the initial cost, because the net present value is negative 4.69. So the answer here is no. Okay. So questions on this type of question where you sum up all the discounted payments and subtract the costs and determine if it's worth the investment? Okay. All right. Everybody doing okay? We're ready for number 6. All right. Let's keep going. If you have questions on the past problems, then just let me know. So, number 6 is on the basic and XP example. So you got this with some missing values, and you got the sensitivity report, which you're going to use to interpret the shadow prices. And let's answer the questions associated with these pictures. Okay, part A. Given the current parameters, let's calculate the objective. So the objective in this problem is total net profit, right? Okay, so remember in this one, there's 2 products. So that means our total profit is the profit we get from the basic computer plus the profit we get from the XP. So there's 2 types of products, which means the total profit is the sum of the 2 types of revenue, right? So the unit margin is how much we make per, and then how many we produce is how much revenue we get. So if we, for the basic, if we make $2.35 for each one, and we produce 100, then the profit for basic is $2.35 times 100. Okay, then plus the profit for the XP, if the unit margin for each one is 485, so this is the margin per unit, and we produce 1,000 units, that means we get 485 times 1,000. Okay? So the first one is for the profit for the basic. The second part is the profit for the XP, and then the total profit is the sum of the 2. So this, put this in your calculator, and you get okay, about $508,500. We're not about exactly. Okay, then part B, identify each constraint as binding or non-binding and calculate the slack, if any. So this one, you just gotta list the constraints, determine if it's binding or non-binding, and then if it's non-binding, you gotta calculate the slack. Okay, so we did this a couple times in class, but let's list the constraints. Okay, and then we'll determine if it's binding or non-binding. Alright, and then if there's any slack, you can calculate that. So let's start with just listing the constraints from this problem. Okay, so the constraints are denoted by an inequality. You see the less than or equal to or the greater than or equal to, and that's the constraint. So the first constraint is the production constraint. So we can't produce more than the maximum sales allowed. There's no inventory in this example. So number to produce is less than or equal to maximum sales for both types. Okay, so we're going to list the one for the basic and one for the XP. Okay, and then we have the other range of constraints. If you go back to the screen cap, and that is the labor constraint. So we can't use more labor than we have available for each type for assembling and for testing. So hours used got to be less than or equal to hours available for both assembling and then also for testing. Okay, so those are the constraints that we listed. So you can't produce more than your maximum sales for both types, and you can't use more labor than you have available for both types. And so when you do this with your take-home exam, the constraints are pretty much going to be the same. So the binding, non-binding, and slack calculations will be different. but listing the constraints should be pretty much the same, so make sure you get this part correct. And so binding means if you use the whole thing, non-binding means there's some slack remaining. Okay, so look at this one. You can see that the maximum sales were 500. We only produced 100. All right, so that means it's non-binding. Okay, and we have the slack is 400, so that's the difference. So this first one, we didn't use it all, and non-binding, and the difference or the slack is 500 minus 100, which is 400. Okay, what about the next one? We can look and see. See the difference? So this is important to know the difference between binding and non-binding. So this one, we were allowed 1,000. We used the whole 1,000. So, okay, see, this is, 1,000 was the max. We used all the 1,000, so therefore this is binding, and there's no slack. So there's no difference, right? Okay, what about the assembling labor constraint? Okay, so see again, the assembling, we were allowed 7,500. We used all 7,500. So there's nothing left there's no difference. It's binding, and there's no slack because we used all of it. So binding, no slack. Okay, last one here, the testing labor hour constraint. Okay, so this one is the other type. This is non-binding. See, we had 5,000 to use. We only used 3,100, so therefore this is non-binding. And the slack is the difference, which is 1,900. Yeah. Okay, so that's what you do there for part B, is you list the constraints. It's going to be these four. Then go determine if we used all of the right side of the constraint. And if we did, it's binding, no slack. If we didn't, it's non-binding, and the slack is the difference between what was allowed and what we used. Okay, then last part, in detail, interpret part C. Interpret all shadow prices in the sensitivity report. So you're going to get a screen cap of that. There it is. And so you got a shadow price of $47 for assembling. Okay, so you should get a positive shadow price for the binding constraints and a zero shadow price for the non-binding constraints, which is exactly what happened here. So just interpret the 47 and the 0. Okay, the shadow price is 47 for the assembly constraint. See this constraint is binding, so that's the value of one more hour for this firm for assembly. Okay, so 47 is the value of one more of the labor hours. The firm gets one more hour for assembly and uses it. Total profit, the objective would increase by the shadow price, $47. And then the other one, okay, this one's non-binding, so an additional hour for testing is worth nothing because we didn't use the original hours that we were given.
So if the constraint is non-binding, then it wouldn't amount to anything because you didn't use the hours that were already given to you?
Yeah. So if you look up, this should confirm what you found in the binding versus non-binding. So the assembly hours were non-binding. Were binding, and the slack was 0. So see that it confirms that we were given 7,500 and we used all 7,500. So that means that getting another one is valuable. In particular, it's worth $7. But this one, we were given 5,000 and we only used 3,100. So getting another hour here is worth nothing to this firm now because they didn't use the original 5,000. Right?
Okay.
That make sense?
Yeah.
Okay. So you can interpret that as such, saying that this additional testing hour is not going to do much for the firm. So okay, so this one, so note that the 0 for shadow price means nothing will happen to the objective. Okay, whereas if there's a positive shadow price, that's the effect on the objective. Okay, so this one, if the firm gets one more hour for testing, nothing will happen to total profit because the firm didn't use all the original 5,000 hours for testing right here, see? Okay, so questions on this one or the constraints or interpreting the shadow prices? Okay, last one, number 7. So we got 10 more minutes, but we can probably get through this, and then I can pass out or post the midterm. All right, so here we go. We got the blending oil example, and you got to calculate or answer some questions based on this one. So this is the last one we did last Thursday. Okay, so part A, given the current parameters, calculate the objective here. So the objective is it tells you the objective to maximize, so you're maximizing total revenue. Okay, so the total revenue is the revenue you get from, there's 4 options of things to sell, if you recall this one. So you can sell gasoline at 60, you can sell heating oil at 50, you can sell any leftover crude oil 1 at 45, and you can sell leftover crude oil 2 at 25. Now this one, only one thing is being sold in final, but I'll put the full equation just so you see. You can use it if the question on the exam is different. So we sold gasoline at 60, and we sold 20,000 barrels. Okay, we can sell heating oil at 50, but we didn't sell any. I'll put it in there anyway, so the price of 50, none sold, so it's 50 times 0. Okay, and then also if we had any leftover crude oil 1, we could sell that at $45. We don't have any left, but we could sell, so it's 45 times 0. The last thing is we can sell crude oil 2 at 25, but there's nothing left, so this is another 25 times 0. Okay, so this is the part for the gasoline, this is the part for the heating oil, this is the part for the crude 1, and this is the part for the crude 2. Now all these are going to be 0, but it's important to note that what we did just in case you sold some. So here are the prices, 50, 45, and 25, and then we sold 0, but if you do sell any, in your example, make sure you put those values instead of 0. Now, the total revenue is just based on gasoline because this is 0, this is 0, and this is 0, so the revenue is just $60 times 20,000. Which is if I got the zeros right, it looks like 1.2 million. All right, and then part B, you can list the constraints and determine if they're binding or non-binding. Again, I think I'm just going to start with what I did before, and then it'll save some time. So let's start with these ones. Okay, so let me just go through the constraints. And so here we have a resource constraint. We can't use more crude oil than we have available for both types. Okay. Okay, and then the other constraint is for the quality constraint. So the quality obtained for both types has to be greater than or equal to the quality required. All right, and then let me just fill in. So you need the resource constraint for both types and the quality constraint for both types. So let me finish that, and then we'll go through the binding, non-binding slack. Okay, so those are the constraints. The two resource constraints, the crude 1 and crude 2, and the two quality constraints for gasoline and heating oil. And if you look at the screen cap, the model, you'll see that most likely that all of the resource will be used. So we used all 10,000 here. We used all 10,000 here, and we exactly met the quality constraints, or we exceeded them. So that means that all of the constraints are binding, and there's no slack, even though this one is bigger than this. Okay, so we exceeded the constraints, there's nothing left. So if you use more than the constraint, it's still binding. So all of these are binding with no slack.
So, I'm a little confused. Why is the quality required binding?
So that one's binding, let's go back to that one. So this one's binding because it's only non-binding if we didn't use all of it. So this is a quality constraint. This one's kind of weird because it's rare that this side is bigger than this. And so think of it as normally the things are less than, so normally we're trying to use, this is the maximum. Like for this one, you can see that we used all 10,000, and this one, we used all 10,000. So this one really has to be binding because this is the quality we have to receive, or we have to match. So we had to get at least 120,000, but we exceeded that.
Oh, okay.
So see how if it's greater than, then it kind of makes it a little, you kind of switch the interpretation because it would only be non-binding if this was less than that. Right?
So it's only non-binding ever if you don't meet the requirement or the constraint.
Yeah, it's only non-binding. It's only non-binding. What's this?
I said, but if you pass the constraint, it would be binding, or if you're equal to.
Yeah, exactly. Yes, that's correct.
Okay.
Yeah, this one's a little bit weird, and it's not. You're not going to see one like this normally, but it's only this one's binding because we set up the model to have to be binding. So the binding versus non-binding interpretation is kind of weird here, but technically it's binding because the one in the exam is going to be binding because if it weren't binding, then we couldn't solve the model. So just know that these two have to be binding, or else it's not going to work. Okay, so these are the constraints, and that was a good question, but yeah, just when you do yours, just when you do this one, it's going to be binding because it has to be, and so the same with, now you got to check these ones because those are the resource constraints, but these two, the quality constraints, they have to be binding or else the model couldn't solve itself. Alright, and then finally, let's interpret the shadow prices for the resource constraints in the sensitivity report. We're almost done. We're a few minutes over, but if you guys stay a few more minutes, then Thursday is going to be, we'll have nothing on Thursday, so stay a few more minutes here, maybe 8 minutes max, and then Thursday there's nothing needed, so you don't have to come if you don't want to. Okay, let's finish this. Okay, let's interpret the shadow prices for the resource constraints. So the resource constraints, right, here are the shadow prices, 15 and 15. So only interpret the ones for the crude oil constraints. These ones don't have a real interpretation, so it only asks for these ones. So this 15 for crude 1, and this 35 for crude 2. Okay, so for crude 1, the 15 shadow price, this is the value of one more barrel of crude 1. Okay, then what's our net profit? So total revenue. Alright, and then interpret the other one for crude oil 2, which is the 35. So this is the value of one more barrel of crude oil 2, $35. Okay, so again, hopefully we see the idea here, but the shadow prices are, if the constraint finding, that's the exact value, and the effect on the objective if you get one more of the thing. So, firm gets one more crude oil one, it's worth $35, so total revenue increases by, $15, increases by 15, and the value of crude oil two each year is $35. So if the firm gets one more barrel of crude two and uses it, then total revenue will increase by the shadow price of $35. Okay, so those are all the questions that you're going to have to answer on your take-home midterm. Any questions? I know we're a few minutes over, but any questions on anything we did here, or just general questions about the exam? Okay, let me. Yeah, this will be posted, and I'll post this to YouTube, just like all the videos, and then I'll post this Word file too, so you can look at the. Yeah. Okay, so. Can you wait, I have some questions. Okay. So can you show part A just on the screen? Oh yeah. Okay, so we got that, and I'll save this, or I did save this, review, and I'll post this, in the midterm section, so you can look at that if you want. And so let me, okay, so we got that. This video will be on YouTube, yes, and then it's due next Tuesday, but I haven't even, let me post the midterm, because this is just the review. Okay, so if you go on Blackboard, I just posted your exam, which is very similar to what we just went through, so you can look at that. Midterm 1, Fall 2020, here it is. I posted some of the students like to use the original or the Word document to kind of write the answers in between, which is fine. So they're both the same thing. You can either work with the Word document or the PDF. It's the same exact thing, but let me just show you what the test is. Alright, so here's your midterm 1. This is all take home. You have a week to do it. Okay, so show all your work to get partial credit. And because there's 7 questions, and the way to make it come out evenly is just to make each one 15 points. So 7 times 15 is 105, so it's the way of the test is the same, but just for mathematical purposes, each question is 15 points, and the total points come out to 105, but it's still based on percent. Alright, and so if you could submit your answer key, either if you're going to do it by hand, try to make it a PDF and email it to me, or you're welcome to like modify the Word document and send that. So whatever you prefer, try to make it your answer key that you turn in PDF or Word document, whichever one is best for you. Okay, and then this is due next Tuesday, October 6th, and you're going to email it to me. So this one, or the exams, the take-home exams, are due by email. So answer sheet preferred as PDF or Word document. Email it to me by next Tuesday, October 6th, and here's my email address. But if you look through, you'll see the questions are very similar. You got one on the bookshelf costs. You got one on the quantity discounts. You got one on the golf club demand. 4 and 5 are on the net present value questions, and then 6 is on the XP and basic computers with the shadow prices. And one we just did, the oil one with the shadow prices is number 7. So there's 7 questions, and hopefully you know how to do them because we just went through the review, but yeah. So questions about the exam? Okay, so again, here's your midterm. The PDF and the Word document are the exact same thing, so work with that, whatever one you want, and make sure you email. You don't have to wait till next Tuesday. If you're done with it sooner, you can send it. You can email it to me, and we'll do that. So that's due in a week. It seems like everyone should be okay doing it because we just went through some practice problems. And then Thursday, I have nothing new planned. And so Thursday is going to be office hours. So I will be here for the whole time. So if you have questions on the exam or anything else, then please sign in. But if not, Thursday is optional. So let me post that.
I tried to open the midterm right now, and it said that Word experienced an error trying to open the file. Let's check the file permissions, make sure there's sufficient signals and other. I'll try the PDF.
Yeah. So are you doing it on your phone?
On my laptop.
On your laptop? And let me try to open it. Okay. It worked on mine. Anybody else having problems opening the file?
Oh, okay. Okay, it worked this time.
Worked that time? Okay.
Yeah.
All right. Okay. So sorry we went over a little bit today, but we're not, class on Thursday is optional. So Thursday, I'm going to be here for office hours. I'll start the meeting, and if you have questions, then please come because I'll just be, sitting here. So Thursday this week, office hours only. If you don't need to come or don't have any questions or are done with the midterm, then you don't have to come. But office hours Thursday. Exam midterm 1 is due next Tuesday by email, and that's it. So thank you guys. Sorry we went a little bit over, but I'll make it up for you with no class on Thursday. So everyone have a good week, and let me know if you have any questions, and stay safe.
Thank you.
Thank you.
Professor?
Yes.
I have a question for number 7.
Okay.
on
On
question
the,
B.
on the exam or the practice one?
The practice.
The practice one, okay. Okay, here we go. Can you see that?
Yeah.
All right. So which part?
Question B. For number 7. Yeah.
Yep.
For the quantity obtained, gasoline and quantity required.
Yep.
I thought it was non-binding.
Oh, so right. So this one here.
Yeah.
Yeah. So I tried to explain this one's a little bit weird, but it is binding because the quality has to be met, or else the model can't solve. So even though because it's a greater than, it's only non-binding if you don't use all of the right side of the constraint. So if you have to,
Okay. So I went over it. Okay.
yeah, we went over, which is fine. So it's only non-binding if there's something left, and there's nothing left because this is a greater than. So as long as you exceed it, it's still binding.
Oh, okay.
Yeah. So these ones on the exam for the quality obtained and the quality required, they might look a little weird, but they're going to be binding. So just know that this one has to be binding, and this one has to be binding, or else the model won't solve. So just kind of assume that these ones are going to be binding, even if the number looks weird like this.
Oh, okay.
Yeah?
Alright. Yeah, that sounds good. Yeah, I understand that.
Okay.
Okay, thank you so much.